Today we're going to take a look at solving some polynomials. So we've been rearranging them, we've been graphing them, we've been looking at the different properties. Today I want to solve some questions. Okay. Last unit we talked about some technology. Here we're going to do the same idea, but we're going to try and do things by hand a little bit. Okay. So for example, you look at this. The first thing here, I want to find out how long a ball is. About 10. And I've given this function about height. Well, I can start substituting things in. I can put 10 in for the height, replace it, call that 10, and I want to solve this question. Okay. To solve the question like that, I have to make my function equal 0. So I'm going to need to rearrange things sometimes. Okay, maybe bring the 10 over here. That way I get a 0 on this side. Okay. If I do that, I've changed the question slightly. No longer am I looking for 10. Now I'm looking for when the equation is equal to 0. In other words, I'm trying to find the zeros. And we know how to do that. We factor things and write down our zeros, right? So really the big idea today, if I want to solve something, find a solution, I want to find my zero, the zero that makes this equation work. Okay, and we're going to try a few of these today. So I've got this lovely equation. I want to solve it. We just said a second ago, to solve something means find the zeros. The format that it's sitting in, factored form, allows me to find my zeros very quickly. What are the zeros of this one? Well, x equals -4 and x equals 6. Okay? We call them the zeros, but they're also the solutions, because if I were to put -4 back in the equation, for instance, -4 plus 4 and -4 minus 6, and I were to do the math on the left-hand side here, and I multiply all those things together, 2 times 0 times -10 is 0. Hey, I've figured out what makes this equal 0. This is true. 0 equals 0. So that must mean that -4 is the solution, which is just sort of a proof of how to find the solution. If I try the next one, what are the zeros? What are my solutions? Well, there's a 0 at 0. There's another one at -5, and there's a third one over here. Now this one's kind of hard to figure out because it's got more than one number in the bracket. And in that kind of case, I write down, I want to know what makes this equal 0, because that's my solution. And then I solve this. Numbers on one side, letters on the other. I divide out both sides by 2, and I get x is 1.5. So this one has 3 solutions. There are 3 different values that make this come out to 0. Okay. If I can make things look like factored form, I can find my zeros, which means I'm finding my solutions. And let's take a look at C. C is not in a great form for us. It's not in factored form. I can't see the zeros, but I know I can factor things. And back to my factoring flowchart. This looks like a simple trinomial. Can I think of things that add to 8 and multiply to 12? Well, things that do that, I need my x's, I need my equal 0. But things that add to 8 and multiply to 12 would be 2 and 6. So now it's a good form to see my zeros, see my solutions. One of them is -2, and one of them is -6. Okay, so for a non-factor form, let's factor it, and then we'll write down our solutions. Okay, let's take a look at D. Now D is different. D is not set up in the right order. To solve a polynomial, it has to equal 0. So I have choices. I can move everything to the left or everything to the right. I'm going to move everything to the left to make it equal 0. That's my objective, because that keeps my biggest term positive. My power of 3 is a positive. And I like to have my biggest exponent being positive. Now that's equal to 0, I'm going to start factoring. What can I do with this? Factoring flowchart. Common factor. They're both divided by 3 and they both have an x. Let's take that out. I'm left with x squared minus 9. Check my brackets. Can I go further? Oh, I got 2 terms. There's a minus sign in the middle, and I can square root those things. That's a difference of squares. Okay, 1 bracket, 2 brackets. Same terms, different signs. Check my brackets. Can I go further? I got no exponents. I know I'm done. Okay, what are my solutions? My solutions, my zeros are, well, I got x is 0. I got x is -3. And I got x is +3. Those are my solutions because those are my zeros. And just to prove it, if I went back to the very beginning of this question, when we had 3x cubed equals 27x, and I tried to see what happens when x is 3. these two things should equal each other, right? If x is 3. So if I put this in my brackets, 3 times 3 to the 3, and this side I put 3 on that side, 3 to the power of 3 is 27. Hey, look at this. I got the same thing on both sides, which means these things are equal, which means sure enough, 3 has to be a solution. And the same thing would be true if I put negative 3 in, or if I put 0 in. Okay, let's look at the next one. So we're just going to do some more practice. Maybe at this point you might want to start working ahead, seeing if you can do some of these, try them out yourself. Okay, check back in, see if you got the right answers. Okay, our objective here, remember, make them equal 0, and then find your zeros. It's not in the right order. Let's fix that. 2x squared minus 11x plus 12 is 0. Right order. Factoring flowchart. I got no common factors, which makes this a complex one. 2 times 12 is 24. Things that add to 11 and multiply to 24. So I got 1 and 24, 2 and 12, 3 and 8, 4 and 6. 3 and 8 can make 11, so let's use those ones. We're going to replace, remember. I need them to be negative, so negative 3x and negative 8x. I'm going to split this in half. I can take out an x. I'll be left with 2x minus 3. My sign comes down. What goes into 8 and 12? Well, 4 does that, so 2x. And 12 divided by negative 4 makes negative 3. I know I'm on the right track. My brackets match. Write down the common one and the leftover one, and there's my factored form. Now, I didn't want to just factor it. I want to solve this, right? So I need my zeros. One of them is easy. This one over here, x equals 4. This other one is kind of hard to tell. So I write down, let's see what makes it equal 0. And then I solve it. Numbers on one side, letters on the other. Divide out that 2, and x equals 1.5. We've solved it. Okay. You guys try the next one. Make it equal 0 first. That's our objective. Start with x to the 4. I'm going to bring everything to the left-hand side this time because I want to make my biggest exponent positive, which it is right now. Back to my factoring flowchart. What comes first? Common factor. I can take an x squared out of all of these things. And I'll end up with a 3-term expression inside. Hey, a 3-term expression, that's a trinomial. A simple one. That adds to 2, negative 2 multiplies to 15. X and x. 5 and 3 seem to work. Negative 5, positive 3. Okay, hey, there's factored form. What are the solutions? Well, I got negative 3 for this one. I've got 5 for this one. X squared, oh, that's a touching 0, but at 0. Okay, there's our solutions. Okay, so our objective, make it equal 0, put in the regular form, and then we factor it. Factoring gives our solutions. So if you take a look at the next two, these are definitely on the right form. In fact, they're not even in our standard form with exponents. They kind of have brackets in them. I can't solve them the way they are, though. To solve these, I need to get rid of the brackets, put in the right order first, and then try factoring. Okay, so I need to be able to do my distributive property, expand my brackets. Oops, not an equal sign there. 2x times 4x makes 8x squared minus 22x. I want to make this equal 0, so I bring it over. Okay. I can common factor. They're all divisible by 2. If I take a 2 out, I'm left with 4x squared minus 11x plus 6. Okay, factoring flowchart. I got trinomial left inside, 3 terms. Looks like a complex one though, so I'm going to multiply these things. 24. Yeah, I think that looks familiar. I had a 24 up here, didn't I? I did, a negative 11. So we know the numbers in the middle already. What were they last time? Minus 3x and minus 8x. And now this time I have an extra piece of that common factor up front, but it doesn't really do anything, right? It just hangs out the front. Okay, split it in half. Common factor each half, 4x minus 3. Notice I got 2 sets of brackets this time, right? My sign comes down. 8 and 6 are both divisible by 2. I got 4x minus 3. I got a second bracket there. Common factor out front. The common part is 4x minus 3. The other part is x minus 2. And there is my factored form. What are my zeros? This one we can see is 2. This one's a little trickier. 4x minus 3 equals 0. Numbers on one side, letters on the other, and I get 3/4 or 0.75. That decimals are fine. And there's none out front. This is not a 0. That's number 2. There's no x there, right? That's not a 0 at all. So I only have 2 zeros, 2 solutions, 3/4 and 2. Okay, try the next one. See what you can do with this one. Okay, I see a bracket squared. I don't want bracket squared. I'd like factor form, that'd be great, but I've got that 50 on the other side, so I can't solve it the way it is. We know that when we see brackets squared, we're supposed to write them out twice. And some of you might be thinking, well, why can't I say the 0 is -4? Well, it's not, because we didn't involve the 50 yet, right? And we have to involve that 50 and put it into standard form before we can actually find our zeros. Okay, so we need to expand these brackets. X squared plus 4x. We're doing FOIL here, right? And the 50 is on the outside of the bracket, not inside the bracket. Okay, get rid of the brackets. Expand everything inside by the 2 out front. Okay, and then we're going to collect all the like terms. So I got 16x's. 32 minus 50 is minus 18. And now I'm ready to solve it. Now I'm ready to factor because it's equal to 0, and I got rid of the brackets. Okay, how do we factor this? First idea, common factor. Take out a 2. Oh, I missed an x here. There should be an x right there, right? 8x minus 9. Check your brackets. Can you go further? It looks like a trinomial. Looks like a simple trinomial. What adds to 8 and multiplies to 9? Well, usually 9 and minus 1 will work. What are your zeros? -9 and +1. And again, we call them zeros, but they're also called solutions. Okay, so far so good, hopefully, solving these things. What do we got left? A little word problem here. Okay. Power of a generator is given by this equation. A is a current in amps. A has to be less than 10. How much power is a generator putting out when the current is 10? Well, it said A is amps, and there it gives us 10, so that must be our A value. Let's put that in for A. Our power equals 100 times A, but we just said A was 10, minus 5 times 10 squared. Now you put this all in our calculator, or if you want to, you can do bed math. That works fine too. 5 times 100, and we got 500, and it said watts. Okay. Part B. What is the current when the generator is putting out 180 watts? Oh, that's the power this time. That's my P. So this time I'm solving. 180 is going to go on the left side. In my equation, 100A minus 5A squared is what I'm left with on the right side. Well, if I'm solving something, looking for solutions, I've got to put in the right order, make it equal to 0, and then solve. This time, I'm going to bring these things to the left-hand side to make my exponent positive. Put in the right order. So 5a squared minus 100a plus 180 equals 0. Our objective is you've got to make it equal to 0 before you start anything, right? All right, let's try factoring this. I should be able to divide them all by 5. A squared minus 20a. 180 divided by 5 is 38. So plus 38. Oh, sorry, that's not 38, 36, my fault. 36. Okay, find numbers that add to 20 and multiply to 36. It's a simple trinomial. I know some things that work. A, what works here? 18 and 2 looks like they're going to work. All right, so what are our answers? Well, A could equal 18, or A could equal 2. There's 2 answers. Okay, if our generator is putting out only 2 amps, or 18 amps, will both generate 180 watts. Okay, there was 2 answers. And most quadratics questions have 2 answers. Okay? I'll put the last example in the last video.